For thousands of years, men believed that Earth is the center of the universe as presented in the geocentric model proposed by Aristotle. They also believed that the Earth is flat and all the natural phenomena in their environment depend on the will of supernatural beings such as gods or goddesses, demons, and other mythical creatures. But with the application of scientific method and the advancement in technology, people were able to polish their beliefs and turn them into scientific principles. So at the end of this discussion, you should be able to demonstrate understanding of volcanoes and oceans. So let us start by defining some terminologies. Geomorphology, it is the study of features of Earth's crust, which are classified according to three primary geologic forces. The first one is diastrophism, which typically produces mountains based on their vertical and horizontal movement. For erosion, it is the physical removal of land masses by geomorphic agent. Example of these geomorphic agents are water, glacial ice, and wind. So diastrophism can occur due to internal pressures, while erosions are caused by forces outside the Earth's crust. And the last one is volcanism, which is associated with the surface discharge of different materials such as magma or hot water. Example of this extrusive volcanism are volcanoes. So what is volcano? A volcano is an opening in Earth's surface where molten rocks, gases, and other pyroclastic materials are being ejected through the crust. So in early times, volcanoes were widely distributed in all the continents of the planets and on the seafloor. At present, of the 859 active volcanoes, 75% of them are located in the Circle of Fire or also known as Pacific Ring of Fire. This circle is the belt of volcanoes that rings the Pacific Ocean. But how do volcanoes form? The volcano formation can be explained using the following methods. The first one is the formation by subduction. So when subduction occurs, one edge of the plate slips beneath the other. So the overlapping of the plates causes the magma to break through the crust, which is the cause of volcanoes' birth. Next is the formation by distension. It is caused by a hotspot near the outer core, the Earth's outer core. So what is a hotspot? A hotspot is a region of high volcanic activity not located at any plate boundary. So volcanoes are formed when magma accumulates in the mountains on the Earth's surface. Magma is contained inside a chamber located inside the mantle. So high temperatures and increased gas pressure keep on helping magma to form either in the upper crust of the mantle or at the base of the crust. When formed, volcanoes undergo several stages. So what are the different parts of volcanoes? The first one is the cone. Aside from being the most striking part of a volcano, it is usually composed of mixtures of lava and pyroclastic. So volcano cones may vary in size and shape depending on the type of magma that is being ejected by a particular volcano. Next is the vent. It is the opening through which an eruption takes place. So this main part of a volcano supplies the magma from the underlying source to the top of the volcano. Next is the magma chamber. It is the large underground pool of liquid rock found beneath the Earth's crust. So volcanoes may have deep magma chamber many kilometers down that supplies a shallow chamber near the summit. Next is the crater. It is a basin-like depression over a vent at the summit of the cone. Next is the caldera. So calderas can be created when a volcano summit is blown off by exploding gases. Or when a volcano collapses due to a vacated magma chamber. Next is the lava. These are the rocks or magma expelled from a volcano during eruption. Its temperature upon ejection can reach up to 700 degrees Celsius. Hence, it flows until it cools and hardens. Next are the dikes. So these are the barriers or obstacles in a volcano. Next are the sills. These are otherwise known as intrusive sheets. Next is the conduit. This is the channel or pipe conveying liquid materials such as magma. The next one, flank. So these are the side of the volcano. Next is the summit, the highest point or apex of a volcano. Throat. So throat is the entrance of a volcano. Next is the ash cloud, expelled in the atmosphere. So volcanic ash or ash cloud is composed of pulverized rock and glass created during eruption. Next are the volcanic bombs. So their sizes may vary and can measure up to 64 millimeter in diameter. Next is the pyroclastic flows. So this includes pumice flow, ash flow, black and ash flow, glowing erupting cloud called avalanche. But in terms of size, particles less than 2 mm diameter are called ash. 2 to 64 mm are called lapilli. And those bigger than 64 meter in diameter are called blacks and bombs. Next is the tephra. These are the fragmented materials that consist of pumice, scoria, lithic materials, or crystals, or the combination of the four. And the last one is the lahar, or the overflowing mixture of volcanic debris and water. So these are also called mud flows. So they are classified as primary or hot, which are directly associated with volcanic eruption, or as cold lahar when they are caused by heavy rainfall. So what are the different types of volcano? So volcanoes are classified in various ways using different definitions and characteristics set by several groups or organizations. But generally, volcanoes are categorized based on the shape of the volcano, the materials they are built of, and the way the volcano erupts. So let us start. The cinder cones, or commonly called as scoria cone, it is the simplest type of volcano in the world. It is a steep conical hill formed above a vent that is composed mostly of basalt. Example of that is the Cerro Negro in Nicaragua. Next are the composite volcanoes, or also called stratovolcano. One of the essential features of a composite volcano is its conduit system, which contains a central or clustered group of vents. Example of that is the Mount Mayon in Albay. Next is the shield volcano. The slopes of shield volcanoes are usually between 2 degree and 2 degree from the horizontal, producing a flattened dome or shield above the crust. So some of the largest volcanoes in the world are listed under this type. Example is the Mauna Loa, which is the largest volcano in the world. Next are the volcanic domes. These are also called lava domes. So lava coming from a dome is too viscous to flow from the vent. Hence, lava piles over around the vent until it cools down and solidifies. Example of this is the Onsen Dome in Japan. So in terms of volcanic activity, volcanoes can be classified according to three based on their ability to erupt. The first one is the active volcano. A volcano is said to be active if it is currently erupting or shown signs of unrest activity, such as significant amount of gas emissions or frequent seismic activities. The next one is the dormant. So, the volcano is declared inactive or dormant if the last traces of volcanic heat disappear and if it has not erupted in 2,000 years. And the last one is extinct volcanoes. When volcanoes exceeded a period of dormancy of at least 10,000 years and are not expected to erupt, they are classified as extinct volcanoes. So, let us have volcanic eruption. So, how do volcanoes erupt? So, volcanoes erupt when molten rock called magma rises to the surface. So, magma is formed when the Earth's mantle melts. Melting may happen where tectonic plates are pulling apart or when one plate is pushed down or is being pushed down. So, if magma is thick, gas bubbles cannot easily escape and pressure builds up as the magma rises. So, when the pressure is too much, an explosive eruption may happen which can be dangerous and destructive. So, what are the different types of volcanic eruption? So, volcanic eruption may be classified generally into two, the magmatic eruptions and phreatomagmatic eruption. But, these two can also be further classified specifically. So, number one is the Hawaiian. So, Hawaiian type of eruption is popular for producing spectacular fire fountains. Example of this is the Mount Kilauea in Hawaii. Next is the Strombolian. So, this type of eruption is known for short-lived and explosive eruptions of lava with intermediate viscosity compared to Hawaiian. Next is the Volcanian. So, this kind of volcanic eruption is an explosive eruption that occurs when the pressure of entrapped gases in a relatively viscous magma becomes sufficient to blow off the overlying crust of solidified lava. Example of this is the Mount Paricutin in Mexico. Next is the Plinian eruptions. So, Plinian eruptions are considered the most explosive and powerful of all eruptions. The strongest types with a VEI of 8 are so-called ultra-Plinian eruptions, as in the case of the eruption at Lake Toba, which occurred 34,000 years ago. So, these eruptions often start suddenly and unexpectedly after a long period of dormancy. It is also termed as Vesuvian eruptions. Okay? So, let us talk about the volcanoes alert levels in the Philippines and in other countries. So, it is really impossible for us to prevent this kind of disaster. So, volcanic eruptions are difficult to predict and most cannot be really predicted. So, to minimize the negative impacts of volcanic activities, geologists use different devices to monitor and record the behavior of a particular volcano. So, here, to reduce death toll and property devastation during volcanic eruptions, the United States Geological Survey, or the USGS, Volcano Hazard Program has adopted an alert notification system. So, this standard system has two parts, a 4-tiered volcano alert level, which is composed of the normal, advisory, watch, and warning, and the 4-tiered aviation color code that is being utilized for all the observatories associated to USGS. So, as you can see here is the summary of volcano alert levels, and here is the summary of aviation color code. So for your normal, volcano is in typical background, non-eruptive state. When there is an advisory, volcano is exhibiting signs of elevated or unrest above known background level. So, in this level, volcano is exhibiting heightened or escalating unrest with increased potential of eruption. When we have this level for warning, there is a hazardous eruption which is imminent, underway, or being suspected. For the aviation color code, for the green, volcano is typical background and non-eruptive state. This is the counterpart of the normal. For yellow, there is exhibiting signs or there are exhibiting signs. The counterpart of this is the advisory here. So for orange, volcanoes exhibiting heightened or escalating unrest with increased potential of eruption. So for the warning, you have the color red. There might be an eruption underway. So this is based on the USGS Volcanic Activity Alert Notification System. So how do we prepare for a disaster, especially for volcanic eruption? So we have here the before, during, what to do before, during, and after a volcanic eruption. This is based on the Philippine Institute of Volcanology and Seismology, the OST PHIVOLCS. Okay? So that ends our topic regarding volcanoes. So let us now proceed with the oceans. So what are oceans? So oceans serve as the planet's largest habitat and also help to regulate the global climate. So ocean currents govern the world's weather and churn a kaleidoscope of life. Human depends on these steaming waters for comfort and survival. So for oceans, the vast amount of water stores the majority of the planet's moisture, terrestrial energy, and heat from the sun. So let us talk about the sea of life. So sea life, what are the different lives that can be seen in the sea? So the Earth's oceans are so vital for life that over 40% of the world's population live 7.4 billion people near coastal areas. So the oceans also hold about 321 million cubic miles of water, which is roughly 97% of Earth's water supply. So as we can see here, sea life are home to millions of Earth's plants and animals, from tiny single organism to the planet's largest living animal, which is the blue whale. So life in the ocean depends on different microscopic organisms such as phytoplankton, which helps in production of about half of the world's oxygen. So what are the compositions of ocean water? So based on these, you have 55% chlorine, 31% sodium, 1.4% other composition, 1.2% of calcium, 3.7% of sulfur, and 7.7% of magnesium. So, based on that, everyone knows that ocean water tastes salty. So that salt comes from mineral deposits that find their way to the ocean through the water cycle. So ocean is composed of many substances. So the salt includes sodium chloride, magnesium chloride, and calcium chloride. So let us talk about the ocean currents. So we all know that ocean water is constantly in motion based on the picture from north to south, east to west, and up down the shore. Ocean water moves all over the place. So these movements can be explained as the result of many separate forces, including local conditions of wind, water, the position of the moon and sun, and the rotation of the earth, and the position of land formations. So for your surface current, wind that blows over the ocean water creates wave. It also creates surface currents, which are horizontal streams of water that can flow for thousands of kilometers and can reach depths of hundreds of meters. So as you can see, surface currents are an important factor in the ocean because they are the major factor in determining climate around the world. So as you can see in the picture, the Coriolis effect causes winds and currents to form circular patterns. So the direction that they spin depend on the hemisphere that they are in. Next is the deep current. So what are these? So these currents are not created by wind but instead by differences in density of masses of water. So based on the picture, these are the thermohaline currents which are created by differences in density due to temperature, which is the thermo, and salinity, which is the haline or the amount of salt. So the blue arrows are deep currents and the red ones are the surface current. So these currents are not created by wind, but the density of masses of water. So what are the ocean's 5 major basins? So number 1 is the Pacific Ocean. So let us talk about it. So the Pacific Ocean, it is the largest of all the oceans. Volume is greater than Atlantic and Indian Ocean combined. So one-third of the Earth's surface is the Pacific Ocean. And it was named after the Portuguese explorer Ferdinand Magellan. So meaning peaceful sea. Next is the Atlantic Ocean. So for Atlantic Ocean, it is believed to be the youngest and formed during the Jurassic period. Here, it is also the world's saltiest sea, and its name was derived from Greek word Atlantikos or Sea of Atlas. Next is the Indian Ocean. So Indian Ocean has its own contribution in the world trade. Besides the navigation routes and mineral deposits, this ocean also has many oil deposits which make about 40% of total world production. It also has the lowest oxygen content. Next one is the Arctic Ocean. So it is the Earth's northernmost body of water. It is the world's smallest ocean, spanning for about 6.1 million square miles, and it is 8% size of Pacific Ocean. And the last one is the Southern Sea. Historically, there are 4 named ocean basins. Those are the Atlantic, Pacific, Indian, and Arctic. However, most countries, including the United States, now categorize the Southern or Antarctic as the 5th ocean basin. So the Pacific, Atlantic, and Indian are the most commonly known. So the Southern Ocean is the newest named ocean basin. It is recognized by the U.S. Board on Geographic Names as the body of water extending from the coast of Antarctica to the line of latitude at 60 degrees south. So, Southern Ocean is also the youngest ocean as it was formed only 30 million years ago when South America and Antarctica moved apart. So what are the significance of the oceans? Number one, for moderate climates. So how is that? So as terrestrial creatures, humans think of the importance of the planet's land surfaces. Yet Earth is a planet consisting of 70% water. So the oceans, along with the atmosphere, distribute heat around the planet. So the oceans absorb heat near the equator and then transport that solar energy to the polar regions. The oceans also moderate climate within a region. At the same latitude, the temperature range is smaller along coastal areas compared to areas farther inland. So next, oceans are also biologically rich. We all know that oceans are an essential part of the Earth's water cycle. Since they cover so much of the planet, most evaporation comes from the ocean and most precipitation falls on the ocean. So, the oceans are also home to an enormous amount of life. That is, they have tremendous biodiversity. So, tiny oceans plant create the base of a food web that supports all sorts of life forms. So, marine life makes up the majority of all the biomass or the total mass of living organisms in a given area. So, these organisms supply us with food and even the oxygen created by marine plants. So, that ends my discussion. Thank you so much.